Build a tiny language AI from scratch. Part 3. How it learns. Loss, backpropagation, and gradient descent. Now, the part that makes it intelligent, or at least look intelligent. Training is one cycle repeated 5,000 times. Predict. Measure how wrong you were. Trace the blame backwards. Nudge the weights. Predict again. Each pass through the whole dataset is called an epoch, and a learning rate of 0.05 controls how big each nudge is. Too small and learning crawls. Too large and the network keeps overshooting the answer. Let's walk through one full cycle.
Step 1. The forward pass, and it's just 3 lines. X matrix multiplied by W1 plus bias gives Z1. ReLU turns that into A1, the hidden activations, the network's internal fingerprint of the 2 input words. Then A1 times W2 plus bias gives 1 raw score per vocabulary word, and softmax turns the scores into probabilities. 2 words go in. A probability for every possible next word comes out. Early in training, those probabilities are basically noise.
Step 2. Measure the damage. For each training example, we look up one single number, the probability the network gave to the correct word. Suppose the answer was learn. If the network said 90%, wonderful. If it said 1%, terrible. Cross-entropy loss wraps that idea in a logarithm. Confident and right costs nearly nothing. Confident and wrong costs enormously. Average it over all examples and you get one number, the loss, that says, this is how bad the network is today. Training is simply the art of pushing that number down.
Step 3 is the famous one, backpropagation. Prediction flowed forward. Now the error flows backwards, from the output back through W2, into the hidden layer, back through W1. Thanks to a beautiful piece of calculus, the combination of softmax and cross-entropy has an almost comically simple starting gradient. Take the probabilities and subtract 1 at the correct word's position. If the answer was learn and the network favored fish, that signal says push learn up, push fish down. ReLU adds one rule on the way back. Neurons that were silent in the forward pass no blame backwards.
Backprop gives every weight a gradient, which direction would make the loss worse. So we move each weight a small step in the opposite direction. That's gradient descent, and it's 1 line per bundle. Weight minus learning rate times gradient. Picture standing on a foggy hillside. You can't see the valley, but you can feel the slope under your feet. So you step downhill. Repeat 5,000 times, and thousands of tiny, individually meaningless corrections accumulate into real structure.
Watch it happen. Epoch 0, loss around 3.8, accuracy 3%, pure guessing. Epoch 1000, loss 1.2, accuracy 65%. By the end, loss near 0.5, accuracy around 85%. And where is all that knowledge stored? Not in a database of sentences. There is no table saying the sky maps to is. Everything the network knows now lives inside those 4 bundles of numbers, W1, W2, and the 2 biases. The weights are the memory. But notice, accuracy never reaches 100%, and the reason is honest. The training data says the sky is blue, the sky is clear, and the sky is bright. So for the input, sky is, there are 3 correct answers, and the network's single top pick can only match one of them at a time. That's not a bug. Language genuinely has many valid next words. Keep that thought, because next episode, this ambiguity is exactly what makes the trained network interesting. We'll ask it something it has never seen.